All right, today we're going to go over some of our free fall problems. First one, we have a tourist drops a rock from rest from a guardrail overlooking a valley. What is the velocity of the rock at 4 seconds? And then there's a second part. What is the displacement of the rock at 4 seconds? Let's focus on the first part. So we're sitting up here. We have the tourist standing up here. They're going to drop this rock. This rock's going to fall. Okay. When they first drop it, right, it hasn't started moving yet. It's kind of just sitting there like my pin. And then it just drops down, right? So at the initial part, we're not moving. My initial velocity is 0. Velocity, okay? And then my time is going to be 4 seconds. How fast am I going at the bottom, right? It says what is the velocity at the bottom? The final velocity is my unknown. But what else do we know? Because we're next to the Earth, that the rock is going to accelerate downward. It's going to accelerate because of gravity, so we call that G. And then acceleration, if we're dealing, it doesn't really tell us we're in feet or meters. Let's just use meters. It's going down 9.8 meters per second squared. And then we got to figure out what equation we have that works for that. We had an equation that said velocity final equals velocity initial plus acceleration times time. Look at that, velocity final, initial, acceleration, and time. The initial velocity is just 0, so it's like we can ignore that. And that just says our final velocity is equal to acceleration times time, which in this case, our acceleration is g. And just plug our numbers in. G is negative 9.8 meters per second squared. And we're going to multiply that by the time of 4.0 seconds. Get Mr. Calculator. It's going to be around 40. Let's figure it out exactly. And we get 39.2, and it's negative meters per second, right? Because seconds and seconds cancel, and we get 39.2 meters per second. And there is a negative, which means we're moving down. So that's all good. Okay, the second part said, what is the displacement of the rock at 4 seconds? So now we're looking at how much did it change position, right? So here's my initial position, and then here's my final position down here. How much was that change in position that I went from here down to there? Well, we have an equation that says a change in position equals initial velocity times time plus 1/2 acceleration, which is g, times time squared. Okay, now again, my initial velocity is 0, so 0 times anything is still going to be 0, so we can ignore that part and say that my change in position is just 1/2 acceleration times the time squared, which is 1/2 times negative 9.8 meters per second squared times 4.0 seconds squared. We're going to have seconds squared and seconds squared, so we're going to end up in meters, which is wonderful because we're going for a displacement. And so we're going to have 0.5 times negative 9.8, 4 squared, and we get negative 78.4 meters. So that distance that I've traveled, and it says it's negative, which is perfect because I went down. Okay, so I'm moving down and I went down. And there we go. There's number 1. Let's take a look at number 2. Suppose the tourist in question number 1, so we're continuing with our same stuff, instead threw the rock with an initial velocity of 8 meters per second. So now my initial velocity is not 0. My initial velocity, right? So instead of just standing there and dropping the rock, they're throwing the rock down with an initial velocity of 8 meters per second down. And if it's down, I have to put the negative in front of it. Determine the velocity and displacement of the rock at 4 seconds. So we're doing the exact same problem. Okay, my time is still equal to 4.0 seconds. My acceleration g is still negative 9.8 meters per second squared, and I'm still looking for the velocity final and my change in position. So we're just redoing the problem, but now we can't cross off that initial velocity. Okay, so we're going to say that final velocity is initial velocity plus acceleration times time, and we're going to call that g now. Our initial velocity is negative 8 meters per second plus a negative 9.8 meters per second squared times my 4 seconds. So we're really going to have the negative 39.2 plus the negative 8, right? Because we're just redoing that part that we already did. Okay, so I'm going to just multiply it all out just to show you that it works. So negative 8 plus negative 9.8 times 4, and negative 47.2, which you notice is just 8 more than that, but going down. So it just took the initial velocity I've had and added it to the velocity I'm going to get because I'm down there. Okay? So what was that? Negative 47.2 meters per second. And now again, we're going to do the same part for my change in position. It's a, excuse me, initial velocity times time plus 1/2 acceleration times time squared. We're going to plug in our numbers again. Initial velocity is 8 meters per second, and it's going down, so that's negative, times my 4.0 seconds, plus my 1/2 times my acceleration, negative 9.8 meters per second squared, times my time, my time of 4.0 seconds, squared, right in the t again. And we're just going to multiply that out. So again, it's just going to add to how far it went because it's traveling faster because I launched it downward. So we're going to have negative 8 times 4. Then we're going to add 0.5 times negative 9.8 times 4 squared. And then we enter all that, and we're 110, so you can see it, 110.4 down. So we just went farther down because we launched it going down instead of just dropping it. Okay, let's look at part 3. Number 3 says, suppose the tourist in question went instead through the rock with an initial velocity up. Okay, so we're doing the same thing again. But now this person right here is going to launch the rock this way. And the rock's going to go up a ways and then head back down. Oops, get you over here we can see. All right, and so now my initial velocity is equal to a positive 8.0. Now we don't normally have to write that plus. I'm just doing it to remind us that things have changed. My acceleration is still negative 9.8. Acceleration is still down, even though I threw it up. Once it leaves my hand, it's not accelerating because of my hand anymore. It's accelerating because of gravity. So we're using the same equations. So velocity final equals velocity initial plus acceleration times time. This is just going to be 8 meters per second plus my negative 9.8 meters per second squared times my 4.0 seconds. So now we're just going to add 8 to that, where before we kind of subtracted, right? So they were the same sign, so it made it bigger. Now they're opposite signs, so now it should make that initial number smaller by 8. So let's look at that. So we have 8 plus negative 9.8 times 4, and we get 31.2, which is 8 added to that 39.2. So that made sense. Okay, so negative 31.2. Now we still ended up going down, right? We're still, our velocity, because after 4 seconds we've already reached the top and we're headed back down, and so our velocity is still going down, but it's not as fast going down because we started off with an initial velocity going up. And then my change in position is still going to be the same equation, initial velocity times time plus 1/2 the acceleration times the time squared. But now it's going to be 8 meters per second times the 4 seconds plus the 1/2 times the negative 9.8 meters per second squared times the 4.0 seconds, whole thing squared. Okay, so let's put all that in the calculator. So we have 8 times 4. And we're going to add that to 0.5 times negative 9.8 times 4 squared. We get to go in, we only moved 46.4. So we didn't go as far because during half that time, or part of that time, we were going up. And so we're still below where we started because we're at negative 46.4. So we're still below where we started, but not as far as we used to be because part of our time was spent going up. All right, I'm going to do the second 2 in a different video so the videos aren't so long.